Let's see here. We got the 5.6 part 2 homework. It needs to be titled that. Define a function. A function is a relationship. Oops, wrong word there. Glad I caught that. Where every element of the domain X has only one element of the range Y. A one-to-one function is true for both cases. Both the domain and range have only one corresponding element. They can't cheat. All right, so, some people talk about the first one saying X can't repeat, can't type. They might say this one, neither X or Y repeat. There's lots of layman definitions of things. What do functions their inverses swap? They swap input X with output Y. To have an inverse, a graph must pass what two tests? It must pass both the vertical and horizontal line test. All right, cool. That's out of the way. I don't want to do that one. I don't want to do that one. Yeah. I'm going to do this one just because of how many kids can't graph a line. All right, so first off is find the inverse of fx. You got 3 steps. You swap x and y. 2, you resolve for y. 3, you replace y with f raised to the negative first. Whoops. Negative first of x, which is read as the inverse of f of x. So this one's actually called f of x. I also like to say you literally get the f out, so it becomes x equals negative 1/2 of y. Add 5. Swapped x and y. So I'm going to subtract the 5 from both sides because Milbrath says do the easy stuff first. All right? So x minus 5 is negative 1/2 of y. To fix that negative 1/2, I'm going to double both sides. And I'm going to multiply by a negative 2 because if I take a negative 2 and I multiply it by a negative 1/2, a negative times a negative is a positive, and it's a positive 1. Use the distributive property on the left-hand side. And now I profit. I do my replacement. The inverse f of net. The inverse of f of x is negative 2x plus 10. Use composition to show that f and the equation that you wrote are inverses. So there's a rule on this for looking at number 7. It says if f of g of x is equal to g of f of x, and it's equal to x, then functions g, f, and g are in fact inverses. So I'm going to find f of g of x. I'm going to let every x and f be that. Okay, I'm going to take this guy and I'm just going to throw it right there. So I've got a negative 1/2. And x has been encountered is getting replaced with negative 2x plus 10. Close my parentheses. And then it says add 5. I'm going to do a cleanup operation here. I'm going to distribute that negative 1/2 to both pieces, okay? So a negative 1/2 times a negative 2, x is just x. And I have the minus 5, and I don't need the parentheses anymore because I use the distributive property, and I have the plus 5 on the outside. I swear I'm trying to change. Is that it? Plus 5 is left on the outside, and I clean that up and I get x. All right, so now I'm going to find g of f of x. So if I look at function g here, which in this case is my inverse, there's a -2 and an x is encountered. I plug in that -1/2 x plus 5, and then you see where it says plus 10 at the end? So plus a 10. You guys do see me changing colors, right? Use the distributive property. -2 times -1/2 x is just x. -2 times 5 is -10, and then there's the plus the 10. Don't forget about that dude. And if I add those like terms, I just get x. So the two functions. Let me say this. Since f of g of x is equal to g of f of x, which is equal to x, the two functions are inverses. Oh, excuse me, bless me. Number 8, sketch a graph of f and its inverse, and also the line of symmetry for the two functions. Oh, wish I could breathe today. So this is mx plus b, bruh. 1, 2, 3, 4, 5. Y-intercept. Fall 1, run 2. And mine ain't gonna be pretty. Freehand graphs usually aren't. The inverse is -2x plus 10. Ah, phooey. First mistake, didn't give myself enough room. I know better than that. Let me get this out of the way. Better. I got a plus 10 on the inverse. You see that guy? 6, 7, 8, 9, 10. It's up here somewhere. And its slope is to fall 2 and run 1. So fall 2 and run 1. It's going to be a lot steeper. There she goes. So this was the inverse of f of x, and this was f of x. Then you're also supposed to do that line of symmetry, which is y equals x. It's centered at 0, 0. It contains 1, 1. And there we go. There's y equals x, my line of symmetry. I'm not doing that one. Let's do a couple of these here. Let's do 13. Again, your 3 steps here, kids, are to swap x and y, resolve for y, and then replace y with the correct notation after the negative first of x. All right, so this y is going to become x, and it would be equal to the square root of y plus 4, because I replaced x with y over 3. And I'm not going to fix division first. I have to actually fix the radical first. So I'm going to square both sides. It'll give me an x to the second on the left-hand side and y plus 4 over 3 on the right-hand side. And I've got 2 more moves to make. I got to multiply both sides by 3. Cancellation on the right-hand side. 3x squared is y plus 4. And the last move I got to do is move that 4 over. 3x squared minus 4 is the inverse of f of x. They're really not that hard. And maybe you'll see a lot of differences going on. You know, we did have division. Now we have multiplication. Again, we're thinking about opposites. We did have addition. Now we have subtraction. And the order is different too. Because here it was add 4 and then divide by 3. Now it's multiply by 3 and then subtract by 4. There's a lot of opposites going on if you'll think about it. All right. I'll do one of the fractions for you. Same steps. X becomes y, vice versa, y becomes x. And, you know, fractions have technically been removed from Algebra 2 standards, at least what we call these rational expressions have, but I don't care. We're doing them anyways. We're going to 3y plus 7 on both sides. The reason we're doing that is because we don't need to have a fraction. Just getting rid of the fraction. We're going to x both sides. 3y times x is going to be a 3yx. X times 7, I'm pretty sure that's a 7, is plus a 7x, and this would equal 2y minus 4. And now the maneuver here is y's on one side, x's on the other, all right, or everything else. But anyways, I'm going to move my y's over here. This guy had a y, so I'm going to call it a y thing. And I'm going to put the rest of the stuff on the other side. This is going over here. I'm going to use my favorite F word of all time, factoring. I'm going to pull a y from both terms. And, you know, kids are like, Milbrath, why'd you do that? Because it generates a desired outcome. You know, why do I brush my teeth every day? Because there's a desired outcome here. I don't have to go to the dentist. That's why I brush them every day. Why do I put my contacts in? Because the desired outcome is I can see. So I counteracted the understood multiplication with division. And this is my inverse, kids, because now it's y equals. So let me put in the correct notation. And ta-da, she is done. You'll notice the time here. It's 3:13 on a Friday. Look at that. Look at that. I'm up here after hours on a frickin' Friday for you guys. And you guys want to sleep in my room. All right, we got 18. It's not bad. Same steps as always. Every x you see becomes a y. Every y you see becomes an x. And now we're going to subtract 12 because this is easy. Always do easy stuff first. Do not be the kid who thinks you can distribute the 5 because you cannot do it because there's a frickin' exponent. So many of you do that. Milbrath shows you something. You're like, you know what, Milbrath, I don't agree with how you're doing math. I'm going to do this. The issue is you're wrong every time. It'd be cool if you were right, but you're not. You're wrong. The opposite of multiplication is division. Cool. So now we have this, x minus 12 sitting pretty over an 8 is y plus 5 all cubed. The opposite of a cube is and always will be a cubic root. Now, remember Milbrath taught you, even though you didn't want to learn it, that you could break up a radical fraction into two distinct pieces here? Turns out the cubic root of 8 is 2. So up top we have cubic root of x minus 12, and this is now equal to y plus 5. We're going to shift that 5 over. Cubic root of x minus 12 is to 2 minus 5, and there is your inverse function. All right, one more, and then I'm done. It's number 20. That's what I'm going to do. And, you know, most kids won't read that. A full 2 out of 3 of you won't even notice it says that. It will be the most missed question on Thursday's test, and there's nothing I can do about that. It's 100% you. I'm going to grab my TI-84, and I'm going to look at the frickin' graph. Like, look at the graph. That'll give you half of it. I don't understand why this is such a hard skill to go to y equals. Like, I want to know what is wrong with you kids. You go to y equals and you type the function in the calculator. Like, this is I honest to God feel that 99% of my students should be able to do this. And I'm beaten down by the fact that you won't do it. You zoom 6. And you can get x values from this graph. Here x is -3, here x is 1. From the graph, x is -3, x is 1. And it does say find all of them. The rest of this is about synthetic division. I'm going to start with a -3. Coefficients are 1, 5, 7, -1, -12. DMA, bruh. I dropped the 1. Negative 3 times 1 is negative 3. 5 plus negative 3 is 2. Negative 3 times 2 is negative 6. 7 minus 6 is 1. Negative 3 times 1 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 times negative 4 is 12. 0. Bam. Move forward. This time, since I got a 0, it's because I got a 0. And it's only because I got a 0 I can keep using those stinking numbers. DMA, drop, multiply, add, multiply, add, multiply, add. Remainder, constant, xx squared. Why did I stop there? Because it was x squared. Because you have been taught for 3 months how to solve something with an x squared. This is x squared plus 3x plus 4. This one was not designed to factor. It does not factor. There are no factors of a positive 4 that add to a positive 3. So you can do x equals negative b plus or minus square root. I'm sorry, I can't sing my voice out. B squared minus 4ac all over to a, and you're going to plug stuff in. A is 1, B is 3, and C is 4. So what do we have here? We have opposite of a positive 3, which is negative 3, plus or minus square root of a 3 that has to be squared, minus a 4 times a 1 times a 4. All sitting pretty over twice a, twice a 1. And I know you think I'm moving too fast. Truth is, you're just too slow. We have a negative 3 plus or minus something. We have a 9 minus a 16, which is a negative 7. Both pieces sitting pretty over 2. Now, I know that the square root of a negative is imaginary. So, negative 3 plus or minus the imaginary root of a positive 7. Both pieces sitting pretty over 2. Ta-da! It's not that hard. None of it is hard. It's you. Quit being you. Just do the work, kids. It's what I'm asking you to do. Do it for me, if not for yourself. I'll play that card.